Hello dear friends, B.Sc. first year semester first, subject chemistry, section 2, unit number 3, part C, Aliphatic hydrocarbons. Subtopic Alkane. In previous few lectures, we discussed about unit number 3, part A and part B. Part A, electronic displacement. Part B, reactive intermediates. Now, in this lecture, we discuss part C, aliphatic hydrocarbons. So first, alkane. But before this, question arises as what is meant by aliphatic hydrocarbons? Now here, myself, Dr. Borul, Assistant Professor and Head of the Department of Chemistry, Late Kumari Durga, Colonel Banmiru, Science College, Dona. Now, what is meant by aliphatic hydrocarbon? Aliphatic hydrocarbon means it is a class of organic compounds which involves some basic or few basic parent compounds of organic compounds as alkane, alkene, alkyne, alkadines. These are the few basic or parent compounds of organic compounds. Hydrocarbon is nothing but compounds containing carbon and hydrogen, and aliphatic is nothing but compounds other than aromatic compounds, open chain compounds other than aromatic compounds. Hydrocarbon means compounds containing carbon and hydrogen only. So first class of aliphatic hydrocarbon, alkane. So in this lecture we discuss about alkane, which is also known as paraffins. Now what are alkanes? विद्यार्थी मित्रांनो, आपण आजच्या ह्या लेक्चर मध्ये aliphatic हायड्रोकार्बन हा जो तिसरा पार्ट सी पार्ट आहे, युनिट नंबर तिसरा मधला 3 नंबरचा युनिट जे आपण स्टडी करत आहोत त्यातला जो हा सी पार्ट आहे aliphatic हायड्रोकार्बन, यामधील अल्केन विषयी आपण माहिती घेणार आहोत. आताच आपण बघितलं aliphatic हायड्रोकार्बन म्हणजे काय. हायड्रोकार्बन म्हणजे कंपाउंड्स कंटेनिंग कार्बन आणि हायड्रोजन. ज्या कंपाउंड मध्ये कार्बन आणि हायड्रोजन असतो ते कंपाउंड म्हणजे हायड्रोकार्बन्स. आता आपण बघणार आहोत अल्केन विषयी. त्याचं दुसरं नाव पॅराफिन असं सुद्धा आहे. So first question, what are alkanes? The aliphatic saturated hydrocarbons containing carbon-carbon single bond and they have general formula CnH2n+2 are called as alkanes. Alkanes म्हणजेच aliphatic saturated hydrocarbon असा हायड्रोकार्बन की ज्यामध्ये कार्बन कार्बन सिंगल बॉन्ड असायला हवे आणि त्याचा जनरल फॉर्म्युला हा CnH2n+2 असा आहे. असे हायड्रोकार्बन म्हणजेच काय तर अल्केन. आता यामध्ये CnH2n+2 असं लिहिलंय. N is nothing but number of carbon atoms. C stands for carbon and H stands for hydrogen. म्हणून डेफिनेशन मध्ये आपण असं दिले यामध्ये the aliphatic saturated hydrocarbon containing carbon-carbon single bond and they have general formula CnH12 plus 2 are called as alkanes. म्हणजे आपण याच्यामध्ये जर पॉइंट्स घ्यायचा विचार केला, इम्पॉर्टंट पॉइंट्स जर सांगायचे असेल तर आपलं असं सांगू शकतो, इट इज अ सॅच्युरेटेड हायड्रोकार्बन. म्हणजे ज्यामध्ये सिंगल बॉन्ड असेल कार्बन कार्बन मध्ये, असा हा सॅच्युरेटेड हायड्रोकार्बन्स आहे. त्याच्यानंतर दे हॅव जनरल फॉर्म्युला CnH12 plus 2. याचा जनरल फॉर्म्युला जो आहे तो CnH12 plus 2 आहे, वेअर या ठिकाणी N इक्वल टू नंबर ऑफ कार्बन ॲटम्स. अँड तिसरा पॉइंट आपण असं मेन्शन करू शकतो, कार्बन सिंगल बॉन्ड हा याचा काय आहे, फंक्शनल ग्रुप आहे. आता आपण काही एक्झाम्पल्स बघणार आहोत अल्केनचे. जसं की फर्स्ट मेंबर जो आहे अल्केनचा तो आहे मिथेन CH4. म्हणजे या ठिकाणी आपण हा जो फॉर्म्युला आहे CnH12 plus 2, यामध्ये जर आपण N इक्वल टू 1 हा पुटअप केला, N ची व्हॅल्यू आपण जर 1 एवढी टाकली तर आपल्याला CH4 हा सुरुवातीचा फॉर्म्युला मिळतो. आणि त्या CH4 लाच मिथेन असं म्हणतात. बघा याच्या नावामध्ये सुद्धा आपल्याला दिसतंय की अल्केन ANE एंडिंग शेवटी काय तिथे ANE आहे. तसे या एक्झाम्पल जो आहे फर्स्ट मेंबर जो आहे याच्या नावात सुद्धा शेवटी ANE आहे. दॅट मीन्स मिथेन. If put N equal to 1, then it gives N equal to 2, then it gives second member of alkane. जर आपण यांची किंमत 2 टाकली तर आपल्याला या अल्केनचा दुसरा मेंबर आपल्याला मिळेल. आणि तो फॉर्म्युला असेल C2H6. त्याला आपण CH3 सिंगल बॉन्ड CH3 अशा फॉर्म मध्ये किंवा बघा इथे स्ट्रक्चर लिहिलेलं आहे या फॉर्म मध्ये आपण त्याला लिहू शकतो. आणि याचं नाव आहे इथेन, ETHANE. सेम अशाच प्रकारे जर आपण N इक्वल टू 3 पुटअप केले त्यावेळेस आपल्याला CH2 CH3 असा आपल्याला फॉर्म्युला मिळेल. CH3 CH2 CH3 म्हणजे यामध्ये आपल्याला C3H8 असा हा फॉर्म्युला मिळेल. हे त्याचं स्ट्रक्चर आहे आणि त्याचं नाव आहे प्रोपेन. मग असंच N इक्वल टू जर 4 पुटअप केलं आपण तर यामध्ये आपल्याला ब्युटेन. N इक्वल टू जर 5 पुटअप केलं तर आपल्याला पेंटेन. N इक्वल टू 6 पुटअप केलं तर आपल्याला यामध्ये हेक्सेन, देन हेप्टेन, ऑक्टेन, नोनेन अँड डिकेन असे आपल्याला यामध्ये मेंबर यामध्ये अल्केनचे पाहायला मिळतात, जे की आपण ऑलरेडी 11वी आणि 12वी मध्ये शिकलेलो आहात. पुढच्या पाठामध्ये आपण घेणार आहोत मेथड्स ऑफ फॉर्मेशन ऑफ अल्केन्स. That means synthesis of alkanes. So first synthesis reaction, Wood synthesis. Wood's name of scientist, that's known as Wood synthesis. The question as write a note on Wood synthesis. Now in answer, alkyl halide react with sodium metal in presence of dry ether, then it gives higher alkane. This reaction is known as Wood's reaction, or the synthesis is known as the Wood synthesis. That means in this reaction, alkyl halide, 2 molecules of alkyl halide react with the 2 molecules of sodium metal in presence of dry ether as a solvent, then it gives alkanes, higher alkanes. This reaction is known as Wood's reaction. General reaction of this Woods reaction as argon X, that means alkyl halide react with sodium metal. Now this is sodium metal, one more molecule of alkyl halides. So here X, that means halides, sodium and halides eliminate in the form of sodium halide, and now this alkyl group attached with this alkyl group to form a higher alkane. To form here higher alkane, and this reaction take place in presence of via dry ether. This reaction is an example of a general reaction of Woods synthesis. Now in this reaction, alkene synthesis or form. Now example of this reaction, when methyl bromide, ethyl chloride, this is an example of alkyl halide. Two molecules of methyl bromide, this one and this one, react with sodium metal in presence of dry ether, then it gives CH3 join with or combine with this CH3, then it gives ethane. That means methyl group react to form ethane, so it gives higher alkane plus twice NABR as a byproduct. In this way, here it gives alkane. Now one more example, when ethyl bromide react with sodium metal in presence of dry ether, then it gives N-butane. Now the two molecules of ethyl bromide react with sodium metal in presence of dry ether, then it gives N-butane. This is an example of Woods reaction. In this way, by using this Woods synthesis or Woods reaction, alkane synthesized or formed. Now second synthesis reaction or formation reaction of alkane as Kohlhaas alkane synthesis. Kohlhaas alkane synthesis. Now in this reaction, alkyl halide first react with lithium metal in presence of ether, then it first gives alkyl lithium. Now the alkyl lithium then react with copper iodide to form lithium dialkyl cuprate. Now the lithium dialkyl cuprate, the reagents acts as the reagents of Kohlhaas alkane synthesis, which attack on alkyl halides, or alkyl halide react with that lithium dialkyl cuprate to form alkane. Now this reaction is known as, it's called as Kohlhaas alkane synthesis. That means here first alkyl halide react with lithium metal in presence of dry ether form alkyl lithium. Now then alkyl lithium react with copper iodide to form lithium dialkyl cuprate. And now same lithium dialkyl cuprate then react with same or different alkyl halide, then it gives alkane. Now this is the general reaction. This alkyl halide react with lithium metal in presence of dry ether, then it gives R bond Li, that means alkyl lithium. Now this alkyl lithium then react with copper iodide to form lithium dialkyl cuprate. This is lithium dialkyl, two alkyl group here, that's known as the dialkyl cuprate. Now this lithium dialkyl cuprate then react with alkyl halide. It may be same or different. It may be same alkyl halide or different alkyl halide. Then it gives alkane. Now example of the Kohlhaas alkane synthesis. How will you prepare propane from ethyl bromide? By using this Kohlhaas synthesis. Now here ethyl bromide first react with lithium metal in presence of dry ether, then it gives ethyl lithium. In general reaction as alkyl lithium, So here example ethyl lithium. Now these two molecules of the ethyl lithium react with copper iodide to form lithium diethyl cuprate. Lithium diethyl cuprate. Now the same lithium diethyl cuprate then react with methyl bromide. That means here used as a different alkyl halide. First alkyl halide ethyl bromide. Now here methyl bromide. That means lithium diethyl cuprate react with methyl bromide to form propane. In this way, by using this Borul's reaction, prepare propane from ethyl bromide. Now, this is two preparation reactions or synthesis reactions of alkane. First, wood synthesis, and our second, coherose alkane synthesis. Now then move towards the next part, which is chemical reactions of alkane. Now here we discuss two chemical reactions particular. First, halogenation. Second, aromatization. So we discuss one by one. First, halogenation. Now what is meant by halogenation? Now halogenation is nothing but the process or phenomena in which replacement of hydrogen atom from alkane by halogen is known as halogenation of alkane. That means here substitution of halogen in alkane is known as halogenation, or simply the process in which replacement of hydrogen atom from alkane by halogen is known as halogenation. Now, in case of halogenation, if substitution of chlorine is taking place, so known as a chlorination. As a substitution of bromine in alkane, so known as bromination. Similarly, chlorination, bromination, iodination as substitution of chlorine, bromine and iodine respectively. Now here in this unit we discuss about the chlorination of alkane. Now chlorination of alkane means the process in which a replacement of hydrogen atom from alkane by chlorine is known as, it's called as chlorination. That means here substitution of chlorine in alkane take place, so known as chlorination of alkane. Now in chlorination, when alkanes react with chlorine in presence of UV light, that means ultraviolet light or mild sunlight, or at high temperature, that means near about 300 to 400 degrees Celsius, it gives mixture of haloalkane. So here as a chlorination, then it gives mixture of chloroalkane. Now the example of this reaction as methane react with chlorine in presence of UV light, that means ultraviolet light, then it gives methyl chloride, methylene dichloride, trichloromethane, carbon tetrachloride. That means mixture of chloroalkane, chloromethane. Now here methane, now this is CH4, methane react with Cl2, that means ClCl, so chlorine in presence of UV light. So first gives methyl chloride. Now the methyl chloride again react with the chlorine, excess of chlorine, and to form methylene dichloride. That means here replace the hydrogen atom from the methyl chloride by the chlorine atom. It gives methylene dichloride. In this way, from the methylene dichloride, again it reacts with chlorine substitute, that means replace one more hydrogen from that methylene chloride, it gives a trichloromethane, which is now also known as chloroform. Now this trichloromethane can react with chlorine, so replace the ending, this hydrogen atom, last hydrogen atom from the trichloromethane, it gives carbon tetrachloride. Carbon tetrachloride. That means this reaction takes place in case of excess of Cl2. So it gives a mixture of methyl chloride, methylene dichloride, trichloromethane, carbon tetrachloride, etc. Carbon tetrachlorides. Now here, if the excess of methane used in this reaction, then it gives methyl chloride as a major products. Methyl chloride as a major products as excess of methane is used. Now this reaction is known as a chlorination of methane. This reaction is known as a chlorination of methane. Now explain the mechanism of chlorination of methane as methane used as excess form. So as methane used in excess form, then what happens? It gives methyl chloride. That means when methane reacts with chlorine in presence of ultraviolet light, then it gives methyl chloride. Now what is the mechanism of this reaction? So question, explain the mechanism of chlorination of methane. Now here, chlorination or halogenation mechanism of alkane pass through the first formation of a free radical. So this mechanism is known as free radical mechanism, or in this mechanism involve the formation of free radical. And now in case of free radical mechanisms, three main important steps occur. These are the common steps in free radical mechanisms. So first step, chain initiation. Step second, chain propagation. Step third, chain termination. These three steps involved in a free radical mechanisms. Now here, in case of mechanism of chlorination of methane, step first, chain initiation. Chlorine molecule undergoes homolysis, that means homolytic bond fission, to give chlorine radical. Now this reaction takes place in presence of UV light, because homolysis always takes place in presence of ultraviolet light at high temperature or in presence of peroxides. And now chlorination is take place in presence of ultraviolet light here. So chlorine react with UV light, then it gives chlorine free radicals. That means equal breaking take place to form chlorine free radicals. Now this is the first step. That means here to form the initiator, which is the chlorine free radicals. So this steps is known as a chain initiation. Now in step second, chain propagation. In this step, the chain initiator, that means chlorine free radical, which is obtained in the first step, attack on methane, and now it gives hydrochloric acid HCl and methyl free radicals. So these methyl free radicals then attack on chlorine molecules to form methyl chloride and chlorine free radicals. Now here in these steps, propagation take place, chain propagation occur. That's why this step is known as a chain propagation. Now in step third, chain termination. In this step, chain propagation steps when any two free radical combines. That means chlorine free radical combine with this chlorine free radical to form chlorine molecules. Methyl free radical combine with methyl free radical to form the ethane. Methyl free radical combine with chlorine free radical to form methyl chloride. That means here to combination of these free radicals, termination of the chain take place. So this steps is known as a chain termination. Now in this way, in the mechanism of free radical mechanisms or mechanism of chlorinations, chlorine molecule react with methane. Chlorine molecule react with methane to form methyl chloride. Now this is the three steps which involved in the mechanism of chlorination of methane. Mechanism of chlorination of methane. Now the question asked in university examination as what is the action of chlorine in presence of ultraviolet light on ethane. This question carries 2 marks. If chlorine react with ethane in presence of ultraviolet light, or chlorine react with propane in presence of ultraviolet light. That means each reaction can have a 2 marks. Each reaction having 2 marks weightage. So now in first, ethane react with chlorine. Now here ethane react with chlorine in presence of ultraviolet light, then it gives ethyl chloride. That means here simply hydrogen atom replaced by the chlorine atom and to form ethyl chloride. Now in second reaction, propane react with chlorine. So propane react with chlorine in presence of ultraviolet light, then it gives ethyl chloride. So here instead of ethyl chloride it gives 2 chloropropane and 1 chloropropane. That means here mixture of 2 chloropropane and 1 chloropropane. And depending upon the stability, 2 chloropropane as a major product. So now here propane react with chlorine, replacement of the hydrogen atom from this position, that means terminal carbon, or from the middle carbons. So as remove from the terminal carbon, then you use 1 chloropropane, and from the middle carbon it gives 2 chloropropanes. It gives the mixture of these 2 products. Out of these, 2 chloropropane is the major products, as the depending upon the stability. Now the second chemical, this is known about first chemical reactions, halogenation, particular chlorination of alkane. Now next chemical reactions, which is aromatization of alkane. Now the name here itself suggests aromatization. That means here formation of aromatic ring from alkane. This process or phenomena is known as aromatization of alkane. Now aromatization means the process in which formation of aromatic ring from alkane. Now here instead of alkyl, here alkane is called as aromatization of alkane. Now the question on the aromatization as how will you convert N-hexane to benzene, or second, how will you convert N-heptane to toluene or methyl benzene. Now so first, N-hexane convert into benzene. How will you convert N-hexane to benzene? Now when N-hexane heated with Cr2O3 and Al2O3 at about 600 degrees Celsius and 10 atmospheric pressure, then it gives, or then N-hexane undergoes aromatization. That means here formation of aromatic ring from N-hexane as benzene. That means here simply terminal carbon atoms join together and replace the hydrogen atom, eliminate the hydrogen atom from the carbon atom and to form a benzene with alternate single and double bond. In this way, by using the Cr2O3 and Al2O3 at 600 degrees Celsius and 10 atmosphere pressure, N-hexane get converted into benzene. That means normal aliphatic compound get converted into aromatic compound. So this reaction is known as a aromatization. Now in second reaction, N-heptane convert into toluene. Now here N-heptane is nothing but 7. So alkane containing 7 carbon atoms. Now this is the N-heptane treated with platinum and Al2O3 at 600 degrees Celsius and 10 atmosphere pressure. Then this N-heptane undergoes aromatization to form toluene. That means benzene ring attached with the methyl group. So this toluene is also known as methyl benzene. Now by eliminating the hydrogen atom, now here eliminate the 4 hydrogen atoms, 8 hydrogen atoms total from the N-heptane and to form a toluene. Now here also N-heptane aliphatic compound convert into aromatic compounds. So this reaction is an example of aromatization. Thank you, dear friends.